Welcome to our next objective, solving and graphing inequalities. Today we'll learn how to solve for x, one part of an inequality, and graph and check our solutions. For homework today, you're going to have a worksheet. Solving inequalities is similar to solving equations, with one exception, which we'll get to tomorrow. To solve an inequality, we want to get the variable alone by doing the opposite to any number on the same side as the variable, same as we were doing with equations. Remember, in order to cancel something out and move pieces, we must add or subtract to give you 0, such as positive 2 and negative 2, or multiply or divide to give you a 1, such as if we had 3x, we would want to divide by 3 to make them cancel out. Let's practice by solving these 1 and 2 step equations. We'll also be talking about how to check our solutions again. So for our first one, x plus 3 equals 7. To get x by itself, we would want to do the opposite of plus 3 and minus 3 to both sides. Positive 3 minus 3 is 0, which is why they cancel out. And we are left with x equals 4. Now, to go and check this, we can take this solution and plug it in for x and check to make sure it works. Is x plus 3 equal to 7? Of course it is. Let's go to our next one. 2x equals 18. We have to do the opposite of multiplying by 2, so divide by 2 to both sides. 2 divided by 2 gives us 1. They cancel out. And it leaves me with x equals 9. When we go ahead and check that solution and take 9, plug it in for x, we're left with 2 times 9. We want to know, is that equal to 18? Of course it is. Our next equation is a two-step equation. We have 3x minus 1 equals 14. Well, we have two things to move, the 3 and the minus 1. We always want to add or subtract first, so the first piece I'm going to move is minus 1 by adding it to both sides. Minus 1 and plus 1 are opposites, which is why they cancel out. And we're left with 3x equals 15. Now we have to get rid of the 3 multiplying to the x, so we're going to divide it to both sides. 3 divided by 3 is 1. They cancel out. And we're left with x equals 5. We're going to go ahead and check that solution. I'm going to take my 5 and plug it in for x, and I want to know, is 3 times 5 minus 1 equal to 14? Well, let's figure this out. 3 times 5 is 15. Is 15 minus 1 equal to 14? Of course it is. Now, those are the only 3 that we're going to check. But remember, with any of these equations that we have, or any equation you ever see, you can always go back and check your work by plugging it in. So here we go. Let's do those bottom ones. Here's another one-stepper. X minus 2 equals negative 9. Let's do the opposite of minus 2 and let's add 2 to both sides. Minus 2 plus 2 is 0. It cancels out. And I'm left with x equals negative 7. For my next one, x divided by 4 equals 5. The opposite of dividing by 4 is multiplying by 4. And anytime we have a 4 on the top and a 4 on the bottom, they cancel out. It gives me a 1. That leaves me with x equals 20. And my last one, 4 plus 2x equals negative 12. These equations are our number one equations that people seem to mess up on. What we want to do here is move a positive 4. And the way to move a positive 4 is to minus it to both sides. So we want to make sure that when we cancel it out, we're canceling it out because 4 minus 4 is 0, which it is. That leaves me with 2x equals negative 16. Remember, when we have the same signs, we keep the signs and add the numbers. Now, next step is we have 2x equals negative 16. To get rid of that 2 that's being multiplied, we're going to divide it to both sides. 2 over 2 gives me 1. It cancels out, and we're left with x equals negative 8. And that's a refresher on solving 1 and 2-step equations. So let's refresh graphing inequalities from yesterday. Step 1. If x is on the wrong side, make sure we flip the entire inequality. And here's an example of what I mean by that. If it reads 8 is less than x is over here on the right side. We want it to be on the left side. So we want to turn it into x is greater than 8. Now, little notice here. Notice the inequality in both still points at the number 8. So our inequality is pointing at our number 8 in our first original. And here, the inequality is still pointing at that 8. Notice both pieces flip sides, and our inequality flips over as well. Number 2. When we make out our number line, the solution goes in the middle. The smaller numbers go on the left side, and the bigger numbers go on the right side. So for our first example is when we have negative numbers. If negative 7 was our solution, negative 7 would go in the middle. Negative 8 would go on the left side. Remember, the more negative the number, the smaller it actually is. Negative 6 would go on the right side because technically it's bigger than negative 7. It's not quite as negative. Here's an example of our positives. If 3 was our solution, it would go in the middle. 2 is smaller, so it's going to go on the left side. 4 is bigger, so it's going to go on our right side. So step 3. If our inequality is greater than or less than, we make an open circle on our solution. If the solution is going to be greater than or equal to or less than or equal to, we make a closed circle on our solution. So for an example, an open circle just kind of looks like an O. Nothing is filled in. If it's supposed to be a closed circle, we want it to be a filled in dot, and that's what a closed circle is going to be. Step 4. If our inequality points right, our arrow goes right. If our inequality points left, our arrow goes left. So we have 2 examples, one of each, and this is going to kind of be a combination of everything. So for our first one, if we have x is greater than 8, what we want to make sure that we do is we make a number line where 8 is in the middle. 7 is going to be smaller, so it's on the left. 9 is bigger, so it's on the right. Since my inequality reads less than, there's no line below, we have an open circle on our 8. Since our inequality points to the right, our arrow goes to the right. For our second example, x is less than or equal to negative 3. So we make out our number line. Negative 3 goes in the middle because that's our solution. Negative 4 is going to go on the left, negative 2 on the right. And because it's reading less than or equal to, it's going to be a closed, filled-in dot at negative 3. Since our inequality points to the left, our arrow goes to the left. And that would be everything all together. We'll be following the same procedure when solving for x in an inequality. Once we have finished, I want us to graph our solution on a number line and then talk about checking our solution. So let's start off by trying one together nice and slow. So here we go. We have x plus 3 is greater than 7. So let's start off by solving. It's going to be the same procedure that we had before for equations. We want to get x alone, and we have a plus 3 that's with it. We want to do the opposite of plus 3, so we'd want a minus 3 to both sides. Plus 3 and minus 3 cancel because it gives me 0. And I'm left with x is greater than 4. So now we go to our number line, and we put 4 in the middle. A smaller number, 3, goes on its left. A bigger number, 5, goes on my right. Now, we have a greater than symbol. no line below it, which means we need to have an open circle on our 4. Since our inequality is pointing to the right, our arrow goes to the right. So we have our solution, we have our graph. But now let's talk about what it means to check. Any number that is on this arrow from our solution means it should work when it's plugged in. Now, let's try that. I'm going to pick number 5. I'm going to plug that in because it should be a number that works for our solution. It's on our solution arrow. And what we're going to do is we're going to take that 5 and plug it into my original. We want to ask ourselves, is 5 plus 3 greater than 7? Well, let's check. 5 plus 3 is 8. Is 8 greater than 7? Of course it is, which means that my arrow is pointing in the right direction, since 5 is a solution. So let's try 4 one-step equations together. Remember, we want to solve, graph, and check. So here's our first one. X plus 5 is less than 45. Let's go ahead and let's solve for x. So, since 5 is attached to the x by multiplication, we want to divide it to both sides, which leaves me with x is less than 9. So we're going to go to our number line and put our solution smack dab in the middle. We're going to pick a smaller number to go on our left, 8, a bigger number to go on the right, 10. Since it reads x is less than 9 and there's no line below it, we're going to put an open dot on our 9. Our arrow points to the left, so our solution arrow is going to point to the left as well. And now we're going to check. We're going to take a number on our solution arrow and we're going to plug it in to see if it works. We want to make sure that 8 is going to work in our inequality. So here we go, we check that out. We want to know, is 5 times 8 less than 45? Let's see. Is 40 less than 45? It sure is, which means yep. Our solution is correct and our arrow looks good. Let's go to that next one. X minus 9 is greater than or equal to 20. Let's add our 9 to both sides, which should give me x is greater than or equal to 29. Let's put 29 smack dab in the middle, a smaller number on my left, 28, a bigger number on my right, 30. Now, since our solution reads x is greater than or equal to, there is a line down below, which means I'm going to have a closed circle on my 29. My inequality points to the right, so my solution arrow also goes to the right. And let's go ahead and let's check. I'm going to plug in 30 to see if it works. I want to know, is 30 minus 9 greater than or equal to 20? Well, let's see. 30 minus 9 is 21. Is 21 greater than or equal to 20? Yes, it sure is, which means that everything is good. Next one. X plus 4 is less than or equal to negative 10. Let's go ahead and solve. The opposite of plus 4 would be minus 4. Let's do that to both sides. They cancel out. And I'm left with x is less than or equal to negative 14. Negative 14 is going to go in the middle. A smaller number, negative 15, is going to go on the left. A bigger number, negative 13 on my right. Now, it reads x is less than or equal to negative 14. That line below means we're going to have a closed dot. Since my inequality points left, my solution arrow is also going to go left. And let's check. Let's see if negative 15 works. Let's plug it in. Negative 15 plus 4 is less than or equal to negative 10. Let's check it out. Negative 15 plus 4 is negative 11. Is negative 11 less than or equal to negative 10? It absolutely is. Negative 11 is more negative than negative 10. For instance, I'd rather owe someone $10 than owe them 11. 11 is going to be a much bigger deal to owe someone than 10. Last but not least, x divided by 3 is greater than negative 2. The opposite of dividing by 3 is timesing by 3. They cancel out, and I'm left with x is greater than negative 6. So let's put negative 6 in, a smaller number on the left, a bigger number on the right. And because it reads x is greater than negative 6, we're going to have an open dot. My inequality points right, so my solution arrow is also going to go right. And we're set. Last one to check. I'm going to take one number on my solution arrow, negative 5, and I'm going to plug it in. We want to know, is negative 5 divided by 3 greater than negative 2? Well, that doesn't go in evenly, so I type it into my calculator, and it gives me negative 1.6 repeating, which we know would round to give me negative 1.7. Is negative 1.7 greater than negative 2? It absolutely is. Negative 1.7 is not as negative as negative 2, which means it's actually going to be greater. Now you're going to try 4 one-step equations by yourself. Remember, we want to solve, graph, and let's make sure you check at least one so that you get in the habit of checking your answers. It's going to be very helpful to be able to check your answers for what we're going to do tomorrow, which is going to be something slightly different from what we're doing today. So go ahead, let's try some out and see what you can do. So here we go for that first one. I'm going to divide both sides by 2, which leaves me with x is less than 9. 9 is going to go in the middle, with 8 on the left, 10 on the right. Should be an open dot that points to the left. When I go ahead and I check, I plug in my 8, and I ask, is 2 times 8 greater than 18? Sorry, is less than 18. And absolutely, 16 is definitely less than 18. It checks out. For my second one, I want to add 4 to both sides, which leaves me with x is greater than or equal to negative 6. Negative 6 goes in the middle, negative 7 to the left, negative 5 to the right. And we have a closed dot that's going to point to the right. Now, if that's not what you have, a couple things might have went wrong. Number 1, check the ordering of those numbers on the bottom. Sometimes those negatives can mess us up. Secondly, double check that adding here. Negative 10 plus 4. We have 6 more negatives than positives, which is why negative 6 is our answer. So let's go ahead and check. I'm going to plug in negative 5. Is negative 5 minus 4 greater than or equal to negative 10? Yep. Negative 9 is greater than or equal to negative 10. It's not quite as negative. Our next one. First thing I'd want to do is I would want to subtract 3 to both sides, which leaves me with x is less than or equal to 4. 4 goes in the middle, 3 on the left, 5 on the right, closed dot, pointing to the left. I go ahead and check. Plug in 3. Is 3 plus 3 less than or equal to 7? Absolutely. 6 is less than 7. It checks out. My last one. X divided by 8 is greater than negative 4. I'm going to times 8 to both sides, which leaves me with x is greater than negative 32. I plug in my negative 32. Negative 33 is on the left. Negative 31 is on the right, with an open dot pointing to the right. When I go to check that solution, I'm going to plug in negative 31. I want to know, is negative 31 divided by 8 greater than negative 4? When I go ahead and I type that in, my solution is going to end up giving me negative 3.875 is greater than negative 4, which is true. Negative 3.875 is not quite as negative as negative 4 is. So let's try 2 two-step inequalities together. So here we go. Our first step, we have 2x minus 3 is greater than or equal to 17. First thing I want to do is move the piece being added or subtracted, in this case the minus 3, by doing the opposite and adding 3 to both. They cancel out because they add to give me 0, which leaves me with 2x equals 20. 2x is greater than or equal to 20. There we go. Now, next step is I have to divide both sides by 2. 2 divided by 2 is 1, which is why they cancel out, and I'm left with x is greater than or equal to 10. There's our solution. Now our graph. I'm going to put 10 smack dab in the middle, with 9 to my left because it's smaller, 11 to my right because it's bigger, with a closed circle on my 10. My inequality points right, so my solution goes right. And now my check. I'm going to take 11 and I'm going to plug it into my original. It's 2 times 11 minus 3 greater than or equal to 17. Well, let's see. 2 times 11 is 22. Is 22 minus 3 greater than or equal to 17? Absolutely. 22 minus 3 is 19. And 19 is definitely greater than 17, so it checks out. Here's my second one. X divided by 4 plus 5 is less than 10. First thing I'm going to want to do is move that plus 5 by minusing it to both sides. It cancels out because it gives me 0. X divided by 4 is less than 5. Now to get rid of that divided by 4, I'm going to do the opposite and times both sides by 4. They cancel out because it's one top and one bottom, and diagonals always cancel. X is less than 20. There's my solution. I'm going to plot down my 20 smack dab in the middle. 19 is going to go to my left, 21 to my right. We have an open dot because there's no equal sign below, and it's pointing to my left. There should be my graph, showing all solutions to this inequality should be on the left side of 20 on a number line. Next, I'm going to check. I'm going to take 19 and I'm going to plug it in. Is 19 divided by 4 plus 5 less than 10? Let's go ahead and see. 19 divided by 4 is 4.75. Is 4.75 plus 5 less than 10? Absolutely. 4.75 plus 5 is 9.75. We all know that 975 is less than 10, which means it checks out, and we're good to go. Now, you try 2 on your own. Let's see what we can do. Remember, we want to solve this, we want to graph this, and let's make sure that we check at least 1 for good practice. Go ahead. So for this first one, we're going to add 10 to both, which leaves me with 4x is less than or equal to 40. Divide both sides by 4, and x is less than or equal to 10. There's our solution. Our graph. Let's plug 10 in the middle. 9 is going to be to my left, 11 to my right. Closed circle. It points left, so my solution draws left. And we check. I'm going to take 9 and plug it in. Is 4 times 9 minus 10 less than or equal to 30? 4 times 9 is 36. Is 36 minus 10 less than or equal to 30? Absolutely. 36 minus 10 is 26, and 26 is less than 30, which means it checks out. So my second one. First step is we're going to minus 8 to both sides. Be really careful with the math. X divided by 3 is greater than negative 18. Make sure you didn't go wrong here. It's a pretty messy 3. Let's go ahead and erase it, make it cleaner. Now, our next step. Since x is being divided by 3, let's multiply 3 to both sides. Which leaves me with x is greater than negative 54. So let's go ahead and plot it on our number line, smack in the middle. Negative 55 is to my left, negative 53 is to my right, an open dot, and it should follow to the right. Let's go ahead and let's check. Plug in negative 53. Negative 53 divided by 3 plus 8. Is that greater than negative 10? Well, let's go ahead and let's try and find out here. Negative 53 divided by 3 is negative 17.7 plus 8. Is that greater than negative 18? Sorry, is that greater than negative 10? Negative 17 plus 8, they have two opposite signs. When I combine that, that's going to end up giving me negative 9.7. Is greater than negative 10, and negative 9.7 isn't as negative as negative 10, which means it checks out. Negative 9.7 is greater than negative 10. So let's talk about equations and inequalities and what they have in common. First thing, solving inequalities and equations follow the exact same procedure. When trying to get x alone, if it's a plus, we're going to minus. If it's a minus, we're going to plus. If it's a times, we're going to divide. If it's a divide, we're going to times. Secondly, we can check both by plugging the solution into our original inequality and making sure it works out. So that's what we have as far as things in common between equations and inequalities. So let's talk about the differences and what makes inequalities so different. So here's what we got. Equations have one exact solution, something that only works. That's why it has the equal sign. Inequalities have series of solutions that are correct. In other words, any number that's on the arrow of our solution is a graph. So if it's going to the left, any number that's less than our solution will work. If it's going to the right, any number that's greater is going to work. Which is the difference. There's a lot of solutions to inequalities. Equations only have one. So let's go ahead and get started on our worksheet. Mrs. Wallace is going to pass it out to us. Have a good one.